Welcome all of you to this video of Maths Made Easy. Now in this video I am going to take up ultrasound in detail. Okay, so examples where ultrasound is used and many different more very interesting things about ultrasound. So let's start. Now in ultrasound, when first thing is, what is our range? What is the human range of hearing? Range of hearing. Okay, the range, now I have talked about frequency before this. The range of human hearing is 20 hertz to 20,000 hertz. Okay, the range of hearing for human beings is this much, 20 hertz to 20,000 hertz. Okay, so now if it is 20 hertz to 20,000 hertz, we humans hear from between this frequency, 20 hertz frequency to 20,000 hertz. Now, if any frequency is below this, okay, that is 5 hertz, 10 hertz, whatever, that is called infrasonic. Okay, that is called infrasonic. And here, if we have more than 20,000, any frequency, any vibration which has a frequency more than this is ultrasonic. Okay, so this is ultrasonic. So we can hear only in this range, but then children can hear a little above this range also. Okay, dogs can hear little above this range. Okay, and there are many animals which can hear below this, and they interact with noise made in this range which we cannot hear. Okay, so here rhinos will hear in infrasonic sound. Okay, they can make sound in infrasonic waves and they also hear this range of vibrations. Okay, then whales, rhinos, whales, elephants, these are the ones which hear in the infrasonic range. If we talk about the ultrasonic range, then we have bats which can produce sound, rats, okay, then dogs and cats, dolphins and porpoises. All these will hear ultrasonic sound in this range, sound in this range. Okay, so now what are the applications of this ultrasound, that is ultrasonic sound waves? Okay, so applications of ultrasound. What are the applications of ultrasound? Firstly, if there are certain machines or satellites or bridges, machine parts which are checked using ultrasound. Okay, machine parts are checked for cracks using ultrasound. So if there is no cracks, ultrasound will just pass through. But if there are cracks, then ultrasound will return back, it will get reflected. So they know there is a crack there. So machines and machine parts and bridges should not have cracks, because if they have cracks which are not visible to the human eye, then it can lower the strength of the machine. Even satellites, okay, they should check for cracks and then send satellites, because these satellites or whatever machine parts we are talking about, they are exposed to a lot of pressure differences, and when they go for a lot of pressure differences, they can get cracks. Okay, so next is, now remember one thing, ultrasounds are high energy, they have a very high energy, small wavelength. Okay, they have a small wavelength, and what else, and high frequency. These are the characteristics of ultrasound vibrations, and this is why it finds so many uses. Okay, so one is checking of machine parts, another is cleaning electronic components. Okay, even watches, they do clean even watches. What they do, they'll put the machine, whatever they want to clean, in a solution, and then they will pass ultrasound through it. Now the vibration will go through the different small parts of this electronic component and take out all the dust and all the dirt that is caught there. It will take out all the dirt and the dust, and it will take out all the dirt and dust, and now it will clean the component. Okay. Third, it is used in removal of kidney stones. Now what they do, this is a without surgery they do it. Now these ultrasonic waves, they are high energy waves, they go and they crash the stones, and the stones are made into powder which are later flushed out through urine. Okay. Next, ultrasounds are used for detecting, that is used many things, detecting abnormal growths. You have heard of lot of scans. So these waves are passed, and any abnormalities, a tumor, a growth, anything, okay, inside the body can be understood by passing ultrasound. So detecting abnormalities in medical science, in medicine. Okay. Ultrasound is also used in echocardiography. Okay, that is where they understand the functioning of the heart, and they understand the various parts of the heart. If something is wrong in the heart, they will understand with the help of passing ultrasonic waves. Okay, so these were few of the uses of ultrasound. Now we come to one very important and interesting use of ultrasound: sonar. What is this? Sonar. Now sonar is sound navigation and ranging. Okay, sound navigation and ranging is the full form of sonar. Now where is it used? It is used for many purposes by ships. Now what they do here, at the base of the ships there will be one transmitter and one detector. Okay, so this is, it can be a transmitter which is useful in transmitting ultrasonic waves. So it is going to send ultrasonic waves at the bottom of the ocean. Okay, this is full ocean, and now this will get reflected back, and it is detected by the detector. This is the detector. Now what does the detector do? The detector is responsible for getting these waves back and converting them to electric signals, which can be interpreted by the detector is responsible for getting the electric signals and converting them to electrical signals. Okay, now we understand that how much time was taken for this wave to go here and then come back. And if we know the speed of the sound waves in water, we can find the distance of this part from the ship base. Okay, we can understand that. Now be it a, why is it used? Now why do we need to understand? Now this kind of waves are used, now sonar is used to understand if there are any sunken ships, any big shoals of any big shoals of fishes, that is used by boats used for fishing also, they use it. Okay, or if there are if there are underwater mountains, if there are any icebergs. Okay, so any icebergs, part of an iceberg can be here. Okay, if there are any other anything else, any other obstruction under the sea, okay, they can understand with the use of sonar. So sonar is a very useful device which lets the ship understand that what is there underneath, is it dangerous, or otherwise for fishing boats, if they can, if there's a big shoal of fish there, they will lay their nets there. Okay, now here again the ship is sending signals and it is getting it back after a time of 3.42 seconds. Now this is again 2D. distance of the seabed from the ship is a d, 2d because it is the return, the sound, ultrasound is reflecting back. 2d is equal to, here distance is speed 1531 into the time 3.42. Okay, so here if I divide, I get 1531 into 3.42 divided by 2, which is 1531 into 1.71. Okay, which comes to 2618 meters. So the distance here to here is actually a little more than 2.5 kilometers. Okay, so that is the distance. Now few things I want you to note in this question. This was a very simple sum, just like an eco question. Now here I want you to note this value. Whenever we were talking about sound traveling in air, we had 344, 346, 340, 330. Okay, now look at this. So I had told earlier that sound travels faster in liquids than in air or gases, and we can see it here. Again, another thing I want to tell, that ultrasound through seawater. So one thing that I want you to see here is through seawater and through regular water, again the speed of sound is going to be different. Here this is through, that is why they are mentioning through seawater. Okay, if they just say water, it can be plain water, but through seawater, depending on the density of the water, the speed of sound will keep on changing. Okay. A submarine emits a sonar pulse which returns from an underwater cliff. So here is a submarine, here is some underwater cliff. It is giving out a pulse and it is returning after a time period of 1.02. Speed of sound in salt water 1531. How far is the cliff? Again, let's take a 2D because it is going and then coming back, and 1531 distance, speed into time, and this is the time. Okay, so here 1531 into 0.51. Okay, which is 780.8 meters. Okay, so it is not, it is a quarter of a kilometer, three-fourth of a kilometer. Okay, so the distance of the cliff is three-fourth of the cliff is three-fourth kind of 780 meters away from the submarine. Okay, bats, as I said, is an animal which use ultrasonic waves for its safety. Okay, so it is a safety mechanism for bats, and also it is a method by which they get their prey. Now bats generally live in caves, okay, dark places, old buildings, okay, where there will be many walls. Now what these bats do is, if there is a wall here, it will give out an ultrasonic wave, and just like our sonar, it has the capacity of understanding how soon the wave came back, the vibration came back, and it can understand if this is a prey or if it is an obstruction. Okay, how far is its prey, how far is its obstruction. Okay, so it can go for the prey or it can keep itself safe from the obstruction. So that is why bats can't see well. Okay, so they can't see very well. In spite of that, they can fly and they can keep themselves safe from all this. They don't go and dash into the walls. Okay, because they can measure this kind of distance. So they also interact between each other using ultrasonic waves. Okay, so that is a very interesting thing in nature to observe. Okay, so few more terms in this chapter. Okay, because CBSE can ask very, very small questions. What is a tone? A sound of a single frequency. Okay, it doesn't change its frequency. That is a tone. What is a note? Sound of a mix of frequencies. Okay, it will have lots of frequencies together. That makes a note. Now I want to talk about, so these are the two words that I thought generally we don't note these things. So these are two words which might be important for you. Okay, so that brings us to the end of this chapter, sound. Okay, my next video is this was my third video in sound, which was on ultrasound. Now my next video in sound is going to take up the questions behind the chapter, because sometimes there are some questions which you can't find an answer of. So I shall be giving all the questions of the chapter sound in my next video. If you haven't subscribed the channel till now, please subscribe it, because lots of more important videos are going to come up very soon. Thanks all of you. Bye.